Jai Bharat to all students. In last two lecture, we have discussed independent event and mutually exclusive event. Okay, so first of all, probably in probability, we have started with the how to solve any probability. What is the equation of probability? Okay, in that we only discuss with the only one event. Okay, now let's say if there are two or more event. Okay, so there is a three possibility. If it is a independent to each other, if it is a dependent to each other, and if it is a mutually exclusive to each other. Okay, so for two or more event, we already discussed independent event. Okay, p of a and b is equal to p of a and multiplied by p of b, or p or p or probability of a or b. Okay, independent. Then mutually exclusive event. Okay, uh, then now in this lecture we will discuss conditional probability, which is how to solve dependent probability, dependent event. Okay, conditional probability, it's also called conditional probability. Condition means it depends on others. Okay, so first of all, let's start with the basic of what is independent and dependent event. Then we will discuss study the what is the conditional probability and how to find conditional probability, what are the formula or equation of conditional probability. Okay, and its related example. Okay, independent events, as a word say, it does not affect by any other previous outcome. Okay, tossing a coin is each toss a independent event. Okay, dependent means which means they can affected by the previous outcome. Okay, example is marbles in a bag. There are two blue and three reds marble in a bag. Now what are the chances of getting a blue marble? The chances is 2 in 5. Okay, there are two blue, so 2 in 5, 2 by 5. Probability of being a blue marble is 2 by 5, one event. Okay, we have to solve with the simple our first lecture formula. Okay, then we have to choose another ball, so that means we have now two event. Okay, so for two event we have to first of all identify that that is independent, dependent, or mutually exclusive. Okay, so the next time if we got now, what is the probability that next marble is also blue? Okay, second times. Okay, so if we choose in first time it is a red, then now there is only 4 marble remaining, 2 blue and 2 red. Okay, and if we choose in first blue marble, so there is only now probability of choosing a blue marble is 1 in 4, because there are only 4 blue, total marbles is remain, in which 3 are red already and 1 is blue, which we have picked. Okay, so this probability is first time for the first event choosing a one blue marble. Okay, now we have to choose, if we have to choose second blue marble, so then we have to depend on what is the first outcome. If it is a red, then probability is 2 by 4. If it is a blue, then probability is 1 by 4. So you can see that probability is changing depending on the previous outcome. Okay, first what is the marble's color was in the first event. Okay, then we have to we can tell that second event choosing a blue marble is that. Okay, so it's depend on the previous outcome. So this example is the dependent event. Okay, if it is a red, then probability is 2 by 4, and if it is a blue marble in first outcome, then its a probability is 1 by 4. So that like Joe. Okay, if we got red marble before in first outcome, then chances of blue marble next is 2 by 4, and if we got blue marble before, the chances of blue marble next is 1 by 4. You can see that both of these probabilities different. It's depend on the what we will get outcome in the first event. Okay, So it's depend on the previous outcome. Depends on the previous outcome. Then we can find the probability of that event, of second event. Okay. So it's called dependent event. Okay. So now this is because we are removing marble from the bag. Okay. So if let's say first we have picked the blue marble, then we can put the blue marble, whichever marble is back in the bag. So first event and second events will remain same. Why? Because there are in first outcome there is a 5 marbles, 2 blue and 3 red. In second outcome also there is a 5 marble, 2 blue and 3 red. Then both of these will become independent event. Okay, if we put marble back into the bag after choosing. Okay, so replacement. Okay, so if we replace the marble in a bag each time, then the chances do not change. Okay, if we pick one marble and then already put in the bag, then also we can second marble, then we after that we put up then in the bag. So all the time bag will remain with the 5 marble, 2 blue, 3 red. Okay, so if we put the with the replacement, then event are independent. Okay, chances don't change. Why? Because there are always going to be 5 marbles. Okay, so after each event probability will remain same. But if we pick up the marble and do not put in the bag without replacement, the event are dependent. Okay, so in a question you have to first of all see that they have given with replacement or without replacement, so that you can identify. Okay, as I said earlier, in exam they will not tell you that this is a dependent event, this is an independent event, this is a mutually exclusive event. Okay, you have to first of all identify that event, then you can use the equation. You already know the formula of all the three event. Okay, but identify the which types of event is asking is difficult. Okay, formula is already know, all the student will know the formula of all the three event. But okay, but in question which is the different types of event are they have asking is important. Okay, is you have to identify, then you can use the formula. Okay, so if in question they have written word like with replacement, then it's independent event, you can use formula. Without replacement means it's dependent. Okay, after choosing marble I pick the marble and do not put in the bag. Okay, so this is a dependent event. Now tree diagram we already know in first lecture of probability, we discussed tree diagram. Okay, so there is a 2 by 5 chances of pulling blue marble. Yes, if we pick blue marble, there is a 2 by 5, 2 blue and overall 5 marbles. If we choose red, there is a probability is 3 by 5 because there is a 3 red and overall 5 marble. Okay, so if we choose blue, then remaining is 1 blue, 3 red. If we choose red, then remaining is 2 blue, 2 red. Okay, now let's say in that bag we have picked one marble. Now what is the probability of being picked blue? It's the 1 and overall 1 by 4. Yes, being picked red as a 3 by 4 or 3 red and overall number of 4. Being in this 2 blue and 2 red, being picked as a blue marble is a 2 by 4, 2 blue, overall 4, and being picked as a red marble is also 2 by 4. Okay, so after that there is a 3 red remaining. If you both of the blue marble. Okay, if one is blue and second is red, then 2 red and 1 blue is remaining. If it is a first is red and second is blue, then 1 blue 2 red remaining, and both are the red marble is 2 blue and 1 red is remaining. Okay, so now we can see that if blue marble was selected first, there is a now 1 by 4 chance getting a blue marble. Okay, first we get the blue marble, then there is a 1 by 4 chances that second marble is also a blue, and 3 by 4 chances of getting a red marble. Okay, now if a red marble was selected first, there is a now 2 by 4 chances of getting blue marble and 2 by 4 chances of getting a red marble. Yes, now our previous answer, what are the chances of drawing true marble? What are the chances of drawing true marble? Okay, so here in first also blue marble and second also blue marble. Okay, so there is a in first 2 by 5 chances followed by 1 by 4 chances. Okay, so we just have to multiply 2 by 5 into 1 by 4. Okay, 1 by 10. So this is a dependent event. Simple. Okay, you have to depend on previous outcome. Okay, formula is simple, it is a multiplication, but it's depend on the previous outcome. Okay, you have to consider the previous result of outcome, result of event. Okay, so our answer is 1 by 10. So chances of drawing true two blue marble is 1 by 10. Yes, now notation. Okay, in previous also independent and mutually exclusive we noted probability. Okay, we already discussed P of A means probability of event A. Okay, so first event A is picking up the blue marble is 2 by 5. Okay, now event B, let's say getting a blue marble second. Okay, but we have two choices. We already know we have two choices. Two in second we have, as we have to pick two marble. Okay, okay, first of all this is a P of A event, our probability of A event to pick up as a blue marble, but our second event is to pick up as a blue marble, but there is a two possibility. Okay, yes, now if we got blue marble first, the chances are 1 by 4. Okay, and if we got red marble first, then chances are 2 by 4. Yes, so we have two choices to get a blue in the second. Okay, so we have to use symbol. How do we merge these two event or outcome? Okay, so we have to say which one we want. Okay, so we use the symbol this given, it's called given. Okay, so P depend on the others. Okay, what we'll get in the first round. Okay, so P of B given A means event B given event A means event A is already happened and it's depend on the event A that event B is going to be. Okay, it's our dependent event. Okay, so for dependent event we have to write like this, it's depend on the previous A event. Okay, if let's say this event name is a D event, so here we have to write down P of B per D. Okay, it's a probability of event B, but it's depend after the event D. Okay, so this name we can you can always given any name. Okay, but what should be write down like this, event B given event A, it's depend on the event A, or B per A, you can also say B per A. Okay, okay, event A has already happened, now that is what is the chance of event B. Okay, it's called conditional probability of B given A. B is dependent on the event A because we have two choices for the outcome of the event A. Okay, already got it. So we have now probability of getting 2 marble is depend on the P of B per A. Yes, it's called P of B per A. This probability is called P of B per A. Okay, not P of B. Okay, it's depend on the previous. Okay, in independent we have to write down like this: PA multiply by P of B, because it's independent. A and B is independent, but now here second event is depend on the other. Okay, so try to different between independent and dependent. We have given the name like this. It depend on the this event. Okay, P of B per A, but our formula will remain same. We have to use instead of P of B, we have to use this notation, P of B per A. Okay, so we do not get confusion between independent and dependent. Formula is same, but only we have given the different notation for the conditional probability. Yes, so our formula will remain same. Instead of P of B, we have to write down its probability of event B, but it's depend on the P of probability of event A, P of B per A. Okay, so it's the same as like this: P of A and B is equal to P of A into P of B per A, or P of B given A. Okay, in what is the formula for independent? Yes, same like this: P of A and B is equal to P of A into P of B. Okay, instead of P of B, we only have write down P of B per A for the difference between independent and dependent event. Okay, it's the same formula just like independent. We have to just multiply by 2 event, outcome of 2 event, but we have to write down that this second event is depend on the first event. Second event B is dependent on the first event. Okay, got it? Probability of event A and B equals to the probability of event A times the probability of event B given event A. Yes, so this is the notation we have to write down in for the conditional probability. Okay, let's start with the example so we can get the better idea. Okay, drawing a 2 kings from a deck. Drawing a 2 kings from a deck. Okay, we already know how many kings are there. 4 kings are there. Yes, in the 52 decks of card. Now, event A is drawing a king first, then event B is drawing a king second. Okay, now say for the first card, the chances of drawing king is selecting a king is 4 out of 52. There are 52 total cards and 4 kings card. Okay, so probability of event A is 4 by 52. Now, after removing a king from the deck, now what is the probability of second card, which is a king? It is only 3 out of 51. Why? Because after choosing one card, there is a number of total of outcome card will be 51 card. Okay, we have to choose one king, so there are now only 51 cards are left, and also there are now 3 kings are left. Okay, so probability of B per A is 3 by 51. Now if we want to write down, if we have put this selecting card back in the deck, then what is the probability? Just like this, P of B is equal to 4 by 52. It does not depend on the probability of others outcome if we put the cards back in the deck. Okay, but here now we have removed the first card, so our second card's probability is 3 by 51, but we have to write down like this: B given A is already happening, or B is dependent on the A. Okay, so now our probability of A and B, both of the king, will be multiplication simple of these two event, 1 by 221. Okay, so simple. we formula is same, independent and dependent event, but we have to give the different notation for the dependent event. Okay, now let's say we have to find second probability, P of B per A. Okay, so for this formula, if we want to find out P of B given A, we have divided like this. Okay, so P of A and B divided by P of A. Okay, this is also a very important formula. Okay, they have given the probability of this P of A and B and probability of A. They have asked the what is the probability of dependent event. Okay, so how let's say that types of example, ice cream. 70% of your friends like chocolate. Okay, chocolate ice cream. 70% of your friends like chocolate ice cream, and 35% like chocolate and like strawberry. Here they have given the word "and," in which 35% of your friends like chocolate and strawberry both. Okay, now we have to find what percentage of those who like chocolate also like strawberry. Who like chocolate also like strawberry. Okay, so in question they have not asked the what is the probability of liking strawberry. They have asked dependent. If the first you have to find out what is the probability of chocolate, then after in which who like chocolate, what is the probability is always going to like strawberry. Okay, so we have to find strawberry is dependent on the outcome of chocolate event. Yes, we have to write down like this, probability of strawberry given chocolate is already happening. Okay, so it's given like probability of chocolate and strawberry like this, and probability of chocolate, we already know what is the probability of chocolate and strawberry is 35%, and probability of only chocolate likes is 0.7. So there is a 50% chance that your friends who's like chocolate is also like strawberry. Okay, simple. Okay, so in question they have asked finding out the second probability. Okay, so this is a conditional probability dependent event. Okay, this is important notation, P of B given A is already happening. Okay, so now this is your today's question of conditional probability. Okay, just like marbles and marbles example, but I have changed the number of marble, and also question ask. Okay, random without a replacement, already given. Without replacement means dependent event. Okay, first marble is red, and what is the probability of second marble is blue? You have to find out second marble. Okay, you can draw tree diagram also, and you can find out from the formula also. Okay, then second example, finding out the dependent probability. Okay, 60% play boys play baseball, and 20% of boys play baseball and football both. So what percent of those that play baseball also play football? Just like our last example. Okay, so both of this question is simple. You can calculate this probability and write it down in book and upload it in RNWIET application. Okay, so now for the next lecture we will talk about in detail of conditional probability, then different types of probability also. Okay, distribution, probability distribution. Okay, so now today's lecture is completed.